class. This video is going to be over section 4.6, which is using trapezoidal approximation to find the area under a curve. This is an approximation. You have spent the majority of the chapter learning how to integrate functions so that you can find the exact area. So remember that Riemann sums and trapezoidal rule are approximations to the area under a curve. So the function that we are going to look at is y equals square root of x. We are going to look at it on the interval between 0 and 4. And instead of inscribing rectangles, we are going to inscribe trapezoids. So let's draw a picture of square root of x. Between 0 and 4, and let's do 4 trapezoids. So if we look at the coordinate point at 4, it will be 4, 2. If we look at 1, it'll be 1, 1. I draw my line straight up, and I make a trapezoid. Now, if you notice, I said trapezoid as I was actually making a triangle for that first one. So if your graph starts at 0, 0, your first trapezoid may actually be a triangle. But if you look how I drew those trapezoids in, it is pretty close to what the actual area is going to be. How do you find the area of a trapezoid? It's 1/2 the height of the trapezoid, base 1 plus base 2. So if I'm going to have 4 trapezoids, I'm going to write out the 4 just like I did when we were doing rectangles. And I'm going to find the area of my 4 trapezoids. Again, this first one's a triangle, but I'm going to go ahead and write it like the area of a trapezoid since that's what we're talking about. Notice, the bases of your trapezoids are the parallel legs. So that means the height of my trapezoids is this length right here. So in this case, all of our heights are going to be 1. Base 1 of my first trapezoid is going to be 0. And the height of my second base will be 1. So the area of my first trapezoid is 1/2. My second one, 1/2 the height, base 1, which is 1, plus this will be base 2 of this trapezoid. So this is base 1 of trapezoid 2, and this is base 2. So to find the length of this base, I have to plug it into my equation. So I get square root of 2. The third one, 1/2 the height. Now if I look at trapezoid 3, I'll do this one in blue. This side on the left is base 1, the side on the right is base 2. So base 2 of trapezoid 2 is the same as base 1 of trapezoid 3. So I will get square root of 2 plus square root of 3. And then my last trapezoid, 1/2 the height, base 1 plus base 2, looks like this. So if I were going to write this out as one big equation, I have 1/2 times 0 plus 2 times 1 plus 2 times square root of 2 plus 2 times square root of 3 plus 2. So you may write it as one big long equation if you want to. We're multiplying 2 by all the middle heights, and the last 2 heights you just write singly. You don't have to multiply by anything. So then I'm going to type this in my calculator, and I get if I round to 3 decimal places, 5.146 as my trapezoidal approximation. If I do the actual area from 0 to 4, that's x to the 1/2. So if I integrate, it looks like this. And if I plug that value into my calculator, I get 5.333. So the actual area is still a little bit larger than what the trapezoid's area is, but it is a pretty close approximation. If you had done left Riemann sums and the right Riemann sum, if you average those two together, you will get the trapezoidal approximation. So left Riemann sum plus right Riemann sum divided by 2 will give you the same answer as if you do the trapezoids. And this is how you use trapezoidal approximation to find the area under a curve. I would like for you to try number 2 on page 314. Good luck, and I'll see you Monday.